definitely will meet somewhere sometime, and I'll visit IIT Jodhpur.
Yeah, sure.
So started, ma'am. Recording is
Yes,
started.
yes, yes. Very good evening to all participants and speaker of this seventh session of AICT sponsored ATAL FDP on AI powered urban futures, advancing sustainability in smart cities. Due to unforeseen project commitments, Dr. Deepak Das is unable to conduct today's session. So, in his place, Dr. Saran Adar, Assistant Professor in the Department of Civil and Infrastructure Engineering at the IIT Jodhpur, will be delivering this session. Dr. Saran Adar's expertise lies in water resource engineering and hydrology, with a primary focus on monitoring, modeling, and understanding of hydroclimatic extremes. Prior to joining IIT Jodhpur, he served as a postdoctoral researcher at the Hebrew University of Jerusalem, Israel. Dr. Adar holds a BTech in Civil Engineering from NIT Raipur and earned a direct PhD degree from IIT Gandhinagar, Gujarat. He has recently been honored as a Young Associate of the Indian Academy of Sciences, Bangalore, and was named as CDRI Fellow for 2024. Additionally, he contributes as an editorial board member for Nature Scientific Data, serves as the chairperson of IEEE GRSS Delhi chapter, and he is a member of the Dam Safety Review Panel. So, Dr. Saran Adar, we warmly welcome to you in this FDP session, and the mic is over to you, sir.
Yeah, thank you, madam. Thank you, Dr. Kiran, and all the organizers for inviting me. So, I hope you all are doing well. So, I request all of you kindly turn on your video so I can feel I am delivering a lecture. Otherwise, it is like I'm speaking to a empty room. Okay, so I will share my slides and start the presentation. Okay, I hope you guys can see the screen. Okay, so yeah, okay, should we start, madam?
Yes, sir.
Okay, thank you. Thank you once again. So our today's lecture is on AI for climate action and urban environmental monitoring. So before we start, we should know about what are the issues, current issues of the climate change, and why do we require this urban environmental monitoring? Right now, there are multiple tools we use, and AI is one of the tools that we can use for climate action and urban environmental monitoring. And this is a efficient tool which can handle multiple aspects of our sustainable cities, not only the environment aspect, it can also uh, solve the many problems related to transportation, water, energy. And those components of the urban system ultimately contribute to our environment. So we cannot just think about the urban environment. When we discuss urban environment, we also need to think about the other vertical of the urban system, which are connected to each or those drives our urban environment. So in the last few years, if you see, there is a large, enormous amount of human activities. There is a emission of greenhouse gases, urbanization, deforestation. It cause there is an increase in our carbon dioxide in our atmosphere, which cause the global warming and our temperature, global mean temperature of the earth increased by around 1 degree in last 100 years or 120 years only. Right. So there is also change in the temperature in the history of the Earth. Like previously, there is a time when Earth's temperature is maybe more than 50 degree, right? Or whatever mean average we have, maybe 30 degrees, so above the 30 degree. But why we are concerned now? Because whatever changes happened in this 1 in 20 year, that never happened. Previously, there is change in temperature. 1 degree change in temperature took around millions of years. But now, whatever 1 degree change in the temperature in just 100 year or 150 years. So that's why we are concerned about this, and this is the that's why we are calling it the climate change. So due to this climate change, what is happening over major impact on our hydrological cycle and environment. If you see the impact on various aspects of the hydrological cycle, like the occurrence of the precipitation, so that has changed in enormous amount. There is a change in the precipitation patterns, precipitation frequency, right? Similarly, there is a change in the snow melt, ice, right, which ultimately contribute to our water resources. And that's why there is a increased frequency of hydrometeorological extremes in the last 50-year and 70-year we can observe. So if you uh, do the literature review of last few decades, there are a number of papers on the climate change, right? Hundreds or thousands of papers on the climate change. Uh, in which they mention how the climate changed in last 100 years or 120 years and how it will change in the future. So for example, how the extreme precipitation change, how the river floods will change in next 100 years, right? So in the last 50 years, the frequency of extreme precipitation and floods have increased across Indian subcontinent, and it will going to increase further in the future warming climate if we do not control the greenhouse gas emission. Right. So it will affect not only our infrastructure, it will also affect our nation's economy, our livelihood. Right. Nowadays, in the urban areas, we can also observe in a small amount of rainfall, there is a flood. Right. So that may be the issue of infrastructure, but the frequency of this, the amount, this precipitation occurrence, that is also changed. So many times you observe, like suddenly there is a heavy rainfall. So whatever rainfall we receive in 24 hour or 2 days, that nowadays we can receive in just 1 hour or 30 minutes. Okay. So that is due to the climate change. So due to the warming, atmosphere now hold more moisture. If atmosphere can hold more moisture, that means the amount of precipitation will be high in a same duration or lesser duration. Similarly, other than the floods or extreme precipitation, the frequency of heat waves and drought also increased. You have observed in last 2 3 years, summers are very harsh. Why? Because of the climate change. If you see the historical analysis of last 72 years, in after 2020, there is a high frequency of heat waves across South Asia. Okay. And you can also observe the trend of this, the frequency of heat wave and the duration of heat wave. Previously, heat wave maybe for 2 days or 3 days. Nowadays, the duration of heat wave is very large. Okay. Similarly, the frequency of heat wave also increased. So it will affect our various aspects of our society, our energy consumption, right? Our crop yield. There may be more forest fires due to the frequent heat waves. Similarly, the drought condition also changed in the last 70 years, or how the risk of drought will change in the next 100 years if we do not control the greenhouse gas emission under the different scenarios. So these are the few studies I have mentioned here. There are many more studies. Okay, those can uh, in those reports or in those studies, you can read how the climate change will affect the hydroclimatic extremes like extreme precipitation, flood, drought, heat wave. Okay, so they are occurring individually as well as they are occurring together. So there is also risk of concurrent and compound hydrological or hydroclimatic extremes. Then, so due to this climate change and climate change induced hazard, there is a significant impact on our water infrastructure, our food availability, and our energy system. If we specifically talk about the energy system, previously you can see due to the flood or heat wave, how, or due to the extreme precipitation, you can easily see, or you can easily find out how the water availability or food availability will change. But these hazards also change over renewable energy production, over energy transmission. Okay. So, for example, we analyzed the power grid disturbances over Rajasthan. Recently, we analyzed this data set and we found there is a significant increase in the power grid disturbances after 2020s. Okay, and after 2020s, heat wave frequency also increased over the Rajasthan. And here in the below panel, you can see here that western part of the Rajasthan facing more power grid disturbances compared to eastern part of the Rajasthan, right? Because here the frequency of heat waves are more. Here the mean temperature, average temperature is higher compared to the eastern part of the Rajasthan. Okay. Similarly, there is a change in the production of the renewable. So this climate change also affect the wind power potential over Rajasthan, right? Similarly, it may also affect the solar renewable. So here you can see in the last 50 years how the power wind power potential has changed over the western part of the India. Right. So this is because of the climate change. So this climate change and climate uh, related hazards, they affect various aspects of our society. Okay, and various aspects or various sectors like water, food, energy, our environment, ecosystem. There is a higher risk of forest fire, human migration, or health effect. So overall, this climate crisis poses significant challenges to our urban system or our cities, our urban areas, towns. And we need to achieve net zero greenhouse gas emission by 2050. There are multiple reports. They are saying we need to achieve the net zero greenhouse gas emission by 2050. India also initiated multiple projects to uh, minimize the greenhouse gas emissions from our end, so we can reduce the severe impact of climate change. So this rapid and far-reaching transition in energy, land, urban infrastructure, or in industrial system, right? If we need to reduce the greenhouse gas emission, we need to focus on our energy system. Right now, majority we are getting power from the thermal plants, right? We need to shift from traditional energy production to the renewable energy. We need to uh, optimize our land cover, uh, land use, land cover changes. We need to efficiently design our urban infrastructure and our industrial system so that we can also reduce the greenhouse gas emission as well as we can reduce the effect of or impact of climate change on our infrastructure system or various components of the urban system. So it demands interdisciplinary technology and innovation. And AI is one of that technology that we can use here to mitigate or to adapt the climate change. Okay, so for the climate change adaptation, okay, so we can use AI-driven solutions for various sectors. For example, we do climate modeling and planning right now. So right now we use some mathematical models, global climate models, right, for the climate modeling. There we have number of parameters, number of uh, components like ocean, atmosphere, land. So there are many parameters, empirical parameters, we do not know about those. So, and many times we need to change various parameters to see how our model performs. So using AI-driven algorithms, we can optimize various parameters of the climate model, right? As well as we can do the climate modeling only based on the AI driven algorithms. Similarly, we can develop the early warning system for natural disaster. Right? For example, if there is a heavy precipitation, so which areas will affected by the flood? So just before rainfall, we can get that information. Right? Similarly, if there is a drought condition, how severe that drought condition will, or how long that drought condition will go. That we can also predict using the AI-based algorithms or AI-based methods. Similarly, we can also do urban resilience planning. So I will go into this urban resilience planning in today's lecture. We will focus more into this urban resilience planning. But other than that, there is application of this AI-driven solution on the Earth observation and remote sensing. Right. So right now we have large number of remote sensing data sets, around many petabyte data available. Okay. So there are number of satellites from ISRO, from NASA, from European agencies, Japan, China, other countries, right? So most of the Earth observation data or remote sensing data is freely available. So we can use AI-driven algorithm and technologies to utilize the data for the urban planning or to develop the early warning system or to develop a climate model, right? Similarly, we can optimize the agri-food system. We can manage our water resources. We can monitor the biodiversity. We can maintain our marine and coastal ecosystem. We can protect them using the AI-based solutions. And we can also predict the land use land cover changes and how it will affect our urban system. Right. So here in this lecture, we will more focus on the urban resilience planning. Why we need to focus on urban sustainability or urban resilience? Because majority of cities contribute towards the greenhouse gas emission. Okay. So cities are the major contributor to the climate change. If we compare the cities or a village or urban area or rural area, so urban area is the main contributor to the climate change. According to UN Habitat, cities consume 78% of world's energy and produce more than 60% of greenhouse gas emission. Right. So here you can see. So if we can efficiently manage our urban system that covers only less than 2% of entire Earth surface, so we can easily minimize our greenhouse gas emission. Right. So these cities contribute around more than 60%. So that's why we need to focus on urban sustainability and resilience. Right. So when we talk about the urban sustainability and resilience, what do you mean by that? Do you have any idea about the urban sustainability and resilience? Majority of you are living in a city, right? So how your city will be sustainable and resilient? What do you mean by that? Anyone can tell me from the audience?
Let me on the mic of the audience.
Yeah,
Just a minute.
yeah, CSG. Please go ahead.
So I've given the speaking access, microphone
Urban
access.
resilience
Hello.
basically
Hello. Good
means
evening, sir.
the concept where any calamity occurs, any natural disaster occurs. It is the ability of the urban area to come back to normalcy as soon as possible. If it can
Yeah,
come to any, if it can come back to the original state or normalcy as soon as possible, it's considered to be more resilient. If it takes
Yes,
a little more time to come back to normal status, it's considered to be moderately resilient. If it is not able to come back to its normal position before the calamity occurred, it's considered to be a non-resilient urban city. I hope
okay.
it's correct.
Yeah, and what about sustainability?
Sustainability is like, you are going to use these natural resources of the city in such a way that, you don't exploit them. You can use them, but you should use in such a way that, you're not exploiting the natural resources, so that, you should pass on this to the next generation
Generation.
also.
Yes,
See, you should not, it's not your jagir, it's not your treasure,
property or yeah.
it's not your
So
property. You got it from
yes,
you got it
so
from your grandfathers.
Ashish
So
Ladaji also want to answer. Ashish
yeah,
Ladaji.
you are very correct.
Yes, sir.
Yes, yeah,
Same sir. Ashish Ladaji
Yes,
also
sir.
want to
Yes,
answer.
sir. Yes, sir. Thank you, sir. Good evening, Saran sir, and everybody. Uh, I'm also agree with the sir that sustainability, urban sustainability means to consume the resources, facilities in such a manner so that they can be maintained continuously. Means we can also fulfill our requirements, but keeping them sustainable, keeping them available for further generation as well as other people. And also resilience means same as sir discussed.
okay. Yeah. So now, if you see right now the situation of our cities, yeah, thank you. I think two candidate or our two of our participants answered this question. So I will ask few more question later, so you guys can answer it. So if you see nowadays our cities or our urban areas, so whenever there is a small amount of rainfall, there is a flood, right? Or maybe if there is a some time during that there is a traffic jam, right? Or suddenly there may be the whenever there is a winter, we can see the poor quality of air, right? So majority of times our urban or urban city, urban area or cities are not resilient, or we are not using the resources wisely, so our future generation can use those resources. So right now, so using AI, we can also make sure we are using the resources sustainably, and our system, urban system is resilient against the various hazards. Okay, so these are the to make urban cities resilient and hazard, we need to do or we need to prepare some climate adaptation and mitigation strategies. So here we can use AI tool to do this climate action. So we can prepare the climate mitigation and adaptation strategies. So in the urban areas right now, if you see there is large number of population, right? And it will grow in the future. And this population are exposed with various risks of climate change such as flooding, extreme precipitation, extreme temperature, water and food shortage, infrastructure damage. Okay, so these require successful climate mitigation and adaptation strategies to prepare our urban areas sustainable and resilient. Okay, and here AI can play a major role. So AI application can help tackle some of these climate change induced issues as highlighted in the previous slides. Okay. And so if we focus only on this urban, if right now we are focusing only on this urban resilience planning, so we need to think about how we can reduce the greenhouse gas emission, right? If we reduce the greenhouse gas emission of each city, we can easily control our greenhouse gas. So how we can monitor that greenhouse gas emission? So in the cities, there are two major contributors of greenhouse gas emission other than the industries. One is your transport management and another is your energy management. Okay, so one sector is transport and another sector is your energy. If we switch from thermal to energy, renewable energy, so we can reduce some amount of greenhouse gas emission, but still we need to do the life cycle assessment, how much money or energy we need to put to develop the, or we need to manufacture the solar panels or wind turbines, right? But still, we need to manage our energy efficiently using AI tools. So if, for example, if you can manage the energy losses through AI technique, so it will also reduce your greenhouse gas emission. Okay, if you can solve the traffic issues, it will reduce your greenhouse gas emission through the transport sector, right? So here, recently at IIT Jodhpur, we developed a digital twin, okay, using the generative causal AI. So this generative causal AI powered digital twin can handle various challenges of our urban system. So we are trying to develop one digital twin for a city. Right now, our case is, study area is Jodhpur city. So for Jodhpur city, we are developing this digital twin so that if there is any climate disaster like flooding, so we can easily handle that situation. Okay, so here we have considered multiple aspects of urban city. So in urban area there is not a one sector. Okay, there are multiple sectors, or these sectors or these components are connected to each other. For example, the transport sector is also connected to your flooding situation. For example, if there is any flooding in one area, okay, so there will be traffic jam. It may affect the other areas, right? Similarly, if there is a water drainage issues and there is a flooding, maybe there is not a heavy rainfall, but due to the drainage issue, there is a traffic jam, right? So drainage is also connected to your flooding. Similarly, water supply is connected to different aspect of your city. Like you will not get, if you are not getting sufficient water, it will affect your daily routine, right? So these are also connected to your greenhouse gas emission. If you require more energy to supply power, then there is a more greenhouse gas emission. So like this, there are multiple issues in the cities. For example, water bodies are depleting in the cities, right? So we need to consider all these components in our digital twin, and we will use this generative causal AI powered algorithms to simulate this digital twin to predict various scenarios and how which scenarios we can adopt so that the emission of greenhouse gases will be less. Okay, or we can uh, secure more water efficiently, our vocabulary can improve, our health can improve, there is a more there is a good environment in our urban area, right? So these all are connected. So for that we have developed this digital twin. So I will discuss this digital twin thing in the later slides. But in this project, there are a number of academic partners, industry partners, and stakeholders with the IIT Jodhpur. So this is not my project, but there are a number of faculties working on this project. So there are faculties from the computer science, faculty from the School of AI and data science, faculty from the civil engineering, electrical engineering. They all are working together and developing this digital twin so that we can solve the many aspects of the urban area and we can develop a sustainable and resilient urban uh, area or urban city. So the objective of our this project is to develop a generative causal AI powered digital twin for Jodhpur city with reinforcement learning for sustainable urban transformation. Right. So here we have considered this is our study area. So we considered the heritage part of the Jodhpur city, like this Ghantagar area or Mehrangarh area, where we have like various heritage sites also. So it is also important if you have the heritage sites, so conserve those heritage sites due to the negative effect of the climate change. Right. If there is a excess, there is a more heating, it will affect your tourists also who are coming from outside the city. Right. Similarly, if there is a frequently higher amount, higher intensity of rainfall, it may affect your heritage sites also, the architect of your heritage site, as well as there are many traditional water bodies. We need to maintain those water bodies also. So, so this in many things, these many things will affect your urban environment. So in urban environment, air is not or water is not one or two component. There are multiple components. So when we deal about the urban system, we need to consider everything. So here in the first proof of concept, we try to develop the digital twin for the transport sector. So that we can solve the traffic issue in this area as well as we can reduce the pollution generated by this transport sector in this area. So for that, so why we are using AI here in this project? Because classical transportation models, they cannot solve the current challenges of our cities, right? They cannot learn from the past data, okay, or from the past experience. And yeah, if there are few questions you can ask, like Dr. Monica Gupta ji raised her hand. So Kamlesh ji, if you can.
Yes, Monica ji and
Oh,
Ashish, you can ask the question.
yeah.
Ashish ji and Monica ji, you have raised your hand. You want to ask something?
If you have anyone, if anyone has any doubt, they can ask anytime, right?
Okay, okay, sir.
Okay. Okay, so if there is no question, we can go ahead. So in the traditional transportation models, they cannot learn from the past data. Nowadays, we have traffic cameras everywhere, right? We have enormous amount of data set. We can utilize that data set, right, to train our model and to manage our transport, right? Similarly, if there is constraints, some constraints, like for example, if there is a rally going on a one part of the city or one part of the your market, right? So you cannot immediately you cannot imagine from where we need to divert the traffic. Okay, so many times these type of AI tools or digital twins can help us to suggest how we can modify our this route of few vehicles or how we can block one road. Okay, so that the people can go from the other areas very easily. Similarly, if there is a heavy precipitation and flooding in few areas of the city, so based on over this digital twin, we can immediately tell them, yeah, these areas are flooded during this amount of the rainfall, so take this route. Okay, so they can save their time as well as it will also uh, emit less amount of pollution.
Dr.
Okay,
Saran, here I would like to, I would request you to please elaborate a little bit on this digital twin, like what
okay,
digital twin means and how it can be interpreted by us.
yes, okay. So yeah, Dr. Manchikant ji here something. Yeah, so first I will take your question, Kamlesh. After that, I will take his question. So, what is this digital twin? So, sorry, I think I forgot to mention about the digital twin. So in our urban environment or in our cities, we have various physical aspects like buildings, roads, right, or drainage, right. There are multiple things we have, right. But if using the remote sensing data set, if we digitize everything, okay, all the aspect of our physical component, okay, so you can get all the data set, everything in your system, right? So this data is your basis to develop the digital twin where you can use various physical based equation or uh, you can solve various mathematical equation, physical based mathematical equation to derive the various components like how your uh, temperature will change over different part of the city, how there is a traffic flow if certain amount of cars or uh, trucks or motorcycles on or your road, how they are distributed. So for that we require various type of data set. First one is your static data set. So static data set like your land use land cover, your buildings, your roads, your drainage line, your water supply lines, everything. So those normally fixed. Okay, those are your static data. So that you require first, and second you require the dynamic data. So that dynamic data you use to solve various equations, various physical equations of the hydrological cycle, okay, or maybe your pipe flow, various, you can solve your pipe flow equation or drainage equation. You can also solve few traffic equations, right? So for that you require the dynamic. If you have this static and dynamic data, then you can use these two data set to develop your digital twin. You can do the simulation. First, you require some you will do some training, and then based on that training, once your model is ready, you can do the prediction or you can generate various scenarios. Okay. Yeah. Next. Yes.
A little more on this. Just a minute, Dr. Manichan. Sir, it is a single layer like a building. We
No,
have
it is not a single layer. There are multiple layers. For example, in a city, one layer may be your land use land cover, like where you have parks, where you have greenery, where you have water bodies. Okay, this is one layer. Since at the same time you have the your building layout. Okay, at the same time you have your water supply line and drainage line. So these all layers you will put together. Okay, that is your static data, and above this static data you will put your dynamic data sets.
okay, okay, sir. Okay.
Okay.
Yeah, may I add a point?
Yes, yes. Yeah. Please
Yeah,
go
Dr.
ahead, Dr. Srinivas.
Yeah, to just add a point to Dr. Sharan's point, like you have when you have a digital twin is an exact replica of the
Replica.
real structure. So when we
Yes.
do earthquake analysis, we subject the digital twin, which is in the computer, to a varied system of analysis, and we understand how this model behaves. And then
Yes.
the way the model behaves is we understand that, and that is how we take precautions to ensure that the original structure which is about to be constructed or is going for retrofit does not suffer. Similarly, water
Yes.
bodies like that. So digital twin, you do all the torture test, the TT. The torture test, all the torture test, you do it on the digital twin, and you understand the resilience of that. And once it's passed the resilience test, then you exact implement on the original structure such that original structure is safe.
Yeah, thank you, Dr. Srinivas. Yeah, so I think Kamlesh, uh, it is clear to you, right? So we will show you a
Sure,
few
sure, sure.
simulations based on our transportation digital twin, right? So where we have performed few simulation, for example, is one road is blocked, from where we need to divert the traffic. It will provide you something. Okay, based on that, you can also estimate how much air pollution you have reduced or how much greenhouse gas emission you have reduced. Okay, so everything you can do on that digital twin. You do not go to the field and divert the transportation in actual. Okay, you can put any condition there and you can do the simulation, or you can see the behavior, how it is behaving. Okay. So there are multiple key points in our model. So the proposed AI model, whatever we are developing this model, is designed to learn from past experience data set. So here in this project, we have also collected a number of traffic data sets, okay, building data set. We did uh, survey there on the field, and we gathered large amount of data set because the data is one of your requirement in your AI model. Okay, so we can understand the spatio-temporal variability in your data set, so that AI model can use it. Then we trained these various using this past data set, we trained our model, we satisfied various constraints of the town planning there, okay, and we applied them. And then we also trained our model to meet the fixed KPIs. Okay, so these KPIs, like if you want to reduce your travel time by 5 minutes or 10% or 20%, or for example, you want to reduce the greenhouse gas emission by 10% or 20%. So what we need to do, these type of scenarios we can do in our digital twin and meet our KPIs. So KPIs is our performing indicators. So generates routing protocols or scenarios. Additionally, this model can be uh, trained to learn the uh, from our user experience, or human can also intervene or provide the feedback. Okay, so reinforcement learning is there. RL feedback means reinforcement learning is there. Okay, or we can also handle the various uncertainties. So as I told you, our case study right now is Jodhpur city, and there are various problems in our selected region. Okay, so to handle these, to solve these problems, we require this digital twin for this area, so we can solve the issues related to the emission of the greenhouse gas, okay, anthropogenic heat generation, okay, compromise safety of pedestrian, vibration induced structural damage to historic building. So these kind of issues we can also solve. Okay, so first in our model, we focused on various aspects. I am skipping few slides so we can complete the presentation on time. So we have gathered the various type of data set. So for example, right now our focus is on transportation and mobility. So we collected the road inventory in that area using the satellite data set, and we also performed a survey to check whatever information satellite provided, that is correct or not. Okay, so we also identify various intersection, okay, middle block traffic information, pedestrian information, availability of parks, water bodies, okay, different type of urban morphology, heritage related area. We have collected urban morphology and heritage related areas so that we can use this dataset later. But right now in our traffic digital twin, we use mostly the transportation and mobility related dataset. And then using this existing dataset, we first trained our generative AI model, and based on that generative AI, after the training of generative AI model, we can get the output of various scenarios. So if you want, if you can give any intended situation, it will give you some solution there. So for example, if there is a flooding in one area, so how you need to divert the traffic. If there is a rally in your area, so how you need to divert the traffic, so it will, there is no traffic congestion in your area or no traffic jam in your area. Okay, and so that we can improve the our traffic flow. We can improve our walkability, since in this heritage area there is a lot of tourism for footfall. So the various people are walking there. So due to the, if there is a traffic jam, they can also easily walk. So we also need to focus how they can improve the walkability. This model, how it can improve the walkability, and how much it will increase the economy of uh, local shopkeepers, okay, as well as how it will increase the tourist footfall, right? So there is a more economic revenue in this area. As well as at the same time, if there is a continuous traffic flow, and if you manage over traffic flow, it will reduce the travel time as well as the vehicular emission, and it will also reduce our energy consumption. Okay. So these are our outcomes. So our model should fulfill these outcomes. So at the end, whatever model we have generated, it provide data set for these, and based on, so there may be few scenarios. This may in those scenarios you can find the vehicular emission is more, energy consumption is more. So we do not need to select those scenarios, right? We will select only those scenarios where we can reduce the energy consumption, vehicular emission, okay, or travel, how we can improve the travel time. So these are the data set, like number of data set we have collected manually from the our study area. So these are the, so we have also collected the data set manually, as well as we have also collected the data from the uh, traffic cameras. So we get the access of traffic camera in that area, and using some machine learning algorithm, we have easily identified the type of vehicle. Okay, here you can see. So for example, this is your car. Here you have three-wheeler, four-wheeler, two-wheeler. Easily you can identify these vehicle. And this data later you can also use in your model to put the information or to train your model. Okay, so because at the end you require this information, otherwise you cannot train your digital. If you have only static data, what you will do with that static data if you do not have the spatial and temporal variability in your traffic, right? So this data we require to train our model.
So, just I want to ask Professor Nadar.
Yeah.
Uh, as you said that you got the access of the cameras. So by installing good quality cameras at different squares, we can
Mm-hmm.
easily like assess the traffic density data, traffic flow data, which earlier was done manually. Someone used to count the number of vehicles passing through a particular section. So all
Mm-hmm.
these things, I think, and they can save a lot of time also. And
Yes, yes, yes. So that's why here you can see these points are showing the camera location. So in our study area, there are like uh, some number of cameras. I do not remember exactly. Actually, some other faculty is working on this area. This is not my domain,
Dr.
but they
Mani,
have collected number
Dr.
of data sets.
Srinivas also want to ask something.
Yes, yes, yeah. Please go ahead, Dr. Srinivas.
The point is, you were mentioning about data sets. My only worry always is how to get quality data sets.
Yeah. So that's why we did the manual survey as well as we collected the data from the camera, traffic cameras. Okay. So there is no chance of any error in those data sets. There are many possibility like in multiple times in remote sensing data set. Okay, there is a issue like the quality of data is not good. So that's why we also conducted the survey there to find out whatever static data we have collected using the remote sensing or drones, those are correct. So we have checked everything. Okay. So okay. So here you can see this is our study area. These green lines are our roads. There are multiple intersections, right? So we have collected the data set for majority of the area covering in this entire our study area. Okay, then based on our various type of data sets, we generate the number of scenarios, possible scenarios using our model. There is static, seasonal dynamic, fully dynamic. Okay. So any type of scenario we can generate. So full dynamic means for each road from a junction, our model output the type of allowed vehicle we can control. We can tell how much is your cars, four wheelers, how many are trucks, heavy vehicle. Okay, how many two wheelers are there? So since we have this data set, okay, so if we need to improve the traffic flow, so many times we can restrict a certain type of vehicle. So for example, in this road, trucks are not allowed or four-wheelers are not allowed, only two-wheelers are allowed. So this kind of dynamic scenarios we can also generate using this model. So I'm not going into the over this AI algorithm and all because this entire algorithm developed by computer science faculty members I fully do not understand. So I'm not discussing that thing as well as this work right now is uh, under publication or we have they have submitted few publications so I cannot disclose that algorithm also but I will show you few scenarios so for example this is your original scenarios where you can see vehicle movement in all four direction of this junction, right? Now for example in you need to restrict the uh, few vehicles, heavy vehicles or four wheelers in one side of your road. Okay, so how you can divert these thing or how the uh, your traffic situation will change over your area. So that simulation you can perform your digital twin. Okay, so cars are allowed from the junction to the left lane. Okay, and generated scenario by our model, no car is allowed from the junction to the left lane. Okay. So originally there is a cars moving towards one side. We want to restrict the car movement on other side, so we can easily check like where this traffic how the traffic distribution will change in different junctions of our study area. So there is no traffic jam at a particular intersection or junction. Later, based on our model, we also calculated the pollutants, like how much emission of different pollutants like CO2, N2O, SO2, PM2.5, PM10. So in original scenario here, you can see this amount of emission. But once we use few scenarios based on the generative AI, then you can find majority of uh, these emission decreased. However, the amount is very less because Right now we are estimating this emission in gram per minute per network area. Since there are multiple network areas, so this amount may be huge if we do the accumulation. Okay, if you accumulate all the network, then it will pose the significant impact on your total emission. Okay, so similarly, we are also developing one our visualization tool, so we can provide this information to the different stakeholders of the city. So people can also easily see where we have the uh, traffic jam, where traffic flow is uh, restricted. Okay, so using the GIS tools, open source GIS tools, we are also trying to develop one this visualization tool showing the traffic situation. Okay, so this work is still under progress, but there are enormous opportunity of AI tools to use in the urban environment monitoring, right? This is the one case study where we can use this for the transportation. Similarly, we can use this for the water bodies rejuvenation also. So in the Jodhpur city, there are number of heritage traditional water bodies. So over the time they are depleted. People are or government or municipality is not maintaining those water bodies. So how we can do the rainwater harvesting house household level, and how we can reduce the effect of uh, flood, as well as how we can rejuvenate the water bodies. So for example, if there is a heavy precipitation in your area or in this study area, okay, so most of the water will go into your drain if your drain size is not sufficient. Normally in India, we have the combined sewer network. There is no separate drainage system for the storm water and the household wastewater, right? So everything going together. So in case during the monsoon season, if there is a heavy precipitation, majority of time our drainage system is full or choked, right? So in that case, there is a flooding scenario. But if you use the rooftop water for the water body rejuvenation, so you can reduce the flood intensity in certain areas. So in that case, you can also use the AI tools to identify how much household need to do the rainwater harvesting, or how much water we need to divert towards these heritage water bodies, so we can reduce the impact of floods. Okay, similarly, we can manage our drainage infrastructure also, right? Or maybe we can optimize the water supply system or wastewater treatment plant in our cities, right? So there are a number of applications in application of the AI for the urban environment monitoring. We can also control our or monitor our air quality, right? And we can maintain our air quality using these AI tools. We just need to do certain simulation in our digital twin so that there is a less amount of pollution in our environment. Okay, so there are number of possibilities of AI tools. So since we have very less time, so I'm moving towards, so I can take few questions also at the end. And right now, it since many of you are working in academia, so I just want to tell you in IIT Gandhi, sorry, in IIT Jodhpur, we take the direct PhD admission from the various CFTIs like NITs. If any student is studying in NITs, they can directly do the PhD at our institute. Right? They do not need to give any exam, any interview. They can directly enroll here. Okay, they just need to uh, register here. If they satisfy the criteria, they directly got the offer letter. They just need to give some registration fees to block their seat, and they can join here for the PhD. Similarly, in my lab, hydro monitoring lab, where we focus on the hydroclimatic extremes, how we can reduce the risk of various hydroclimatic extremes such as droughts, heat wave, extreme precipitation, right? Uh, Using the traditional hydrological modeling is as well as the advanced AI machine learning methods or remote sensing. If you are interested, if you know someone who is working related to this area, you can ask them to email me. I have many JRF, SRF positions in my laboratory. They can join here anytime. I also have few PhD positions. If anyone interested, they can contact me. So thank you. So if you have any question, we have sufficient time for the discussion. So we can discuss various aspects of the our urban climate action and the urban environment monitoring.
Uh, Before I even ask, having the privilege, I would like to ask one question, Professor Saran. Like as you
Yeah,
said
please
that
go ahead.
through this digital twin, so I was thinking of scenario when we have sufficient number of cameras
Mm-hmm.
installed at all the locations of the city, and
Yes.
at times we find that there are many sensitive areas where
Mm-hmm.
riots can take place on some special days. So
Mm-hmm.
if cameras are stored at all locations and they are being monitored through AI, so at the
Mm-hmm.
moment the crowd starts to accumulate at any particular point, it can give us
Mm-hmm.
an alert that yes, that particular area is having some accumulation of people, and that can be a point of concern. So in that way, we can very early predict uh,
Yes.
such
So
things.
that is one application, right? So it is a early warning type of system you can create, right? You just need to design a algorithm. If there is if the number of people are more than a certain threshold, your system will alarm you, right? So this is very simple application. So you do not maybe require AI in that case.
Okay, okay. And one more
Right.
point generally comes to my mind that at times we find that there are many unsocial elements in the city, like thieves and all those people. So once their identity is being logged in our digital data set, and
Mhm.
then our cameras are already stored at different locations of the city. So whenever that person is found at anywhere, or whenever that person punch or he's found in the camera of any like mall or showroom, he can immediately be detected that that person is at the particular point. So that AI can also be useful in that those scenarios
Yes,
to
yes. AI can help us in that scenario. The only constraint is that we require the high quality footage, right? Many times, if we do not have high quality footage, we can also convert the low quality footage to high quality footage using the AI and ML tools. So there are number of papers you can find related to this area. Right.
definitely.
You just need to identify that person based on their feature. Okay. It will take one screenshot, compare those images, and it will immediately tell you there is the same person or not. Yeah, Professor Srinivas, please go ahead.
Yes, yes. Now, again, coming back to my old, the previous doubt regarding data sets, when we are working, we want to train a model, we need some data. So,
Yes.
for every problem which we take up, uh, quality data sets may not be available.
Sure.
So,
Yeah.
for example, if you, you presently, if you want to use free data sets, we go to Kaggle.
Mm-hmm.
Now, there are data sets which, for which you have to pay also, but payment is very high. But
Mm-hmm.
until unless you have quality data, you can't train the model. The model will not learn properly. So
Mm-hmm.
there are so many challenges. I don't know how to come out of this problem.
Yeah, so in we have many areas where sufficient data sets are not available.
Correct.
So yeah, so for example, when we start this project on the traffic, that time we do not have the sufficient amount of traffic data. And
Hmm.
getting this camera footage is another challenge because normally government do not share these camera footage to any institute, right? So we need to approach the commissioner here. Then we also need to approach the police commissioner of the Jodhpur city. Then they gave access to us, right? So it is a
Correct.
challenge. I agree with you. But somehow we need to collect the data set because that is a requirement. If you do not have data set for your area, maybe for any other area, you must have that data set. So initially you can train your model using that data set. You can get some patterns, you can get some constraints from that, you can extract some feature from that data, and later those parameters you can use for your study area. But it is always it will not work always, right? For example,
Correct.
in Indian cities we have different kind of challenges those we do not have in USA, Europe, or any developed nation, right?
Correct.
So we cannot directly
Copy paste.
utilize their data set to study the Indian cities. So in that case, somehow we need to manage data from city authorities. So I think you need to approach the city authorities and try to get the data set. There is
I
some
keep-
struggle, but ultimately you
Hmm.
will get the data.
While I keep telling my students only one point: your model is as good as your data only.
Yes, yes, agree. I also agree with this. So
Thank you.
in since I'm working in this hydrology or water resources area, so many times we have data set of precipitation temperature, but we do not have a data set of stream flow, right? So in that case, what we do, we use some established physical based laws or physical based models to
Hmm.
first simulate or generate that data set. Right. And
Correct.
using
Correct.
the data set, then we can train our model.
Correct.
Similarly, here we have collected data set for a few days, right? So
Correct.
then later what we did, we used one transportation model. Okay. Using that model, we extended this data set for many months.
Correct.
Then we utilize this data set for our machine, this AI, generative AI model. So
Correct.
there are few techniques those you need to try. Based on that, maybe you can enhance the quantity of your data set, and you can use these tools for the your research purpose or to solve that problem.
Yeah. Thank you. Thank you.
Thank you so much. Yeah, Professor.
Okay, anyone else from the audience would like to ask some question? Dr. Vijay is saying thank you very much, sir. Okay, Dr. Vijay, if you can have some questions. Anyone? Okay, no questions. Okay, okay. Uh, yes, that's okay. Professor, one more thing I would like to know from you. As you said that today, because of many satellites, many types of many data is available to us. Remote
Mm-hmm.
sensing data is available to us. Just can you suggest some of the sites from where we can have some remote sensing data?
Okay, there is one ultimate platform for the remote. If you are interested, anyone interested in the remote sensing data set, or if they are working related to remote sensing, you don't need to download any data set. You do not require even computational power at your institute or with you. You just need to go to the Google Earth engine, create your account there. There is multiple petabytes data freely available. Okay,
Okay.
Google Earth engine, just search Google Earth engine. You just need to log in. You will get the data set there. They kept all the data set in their cloud server.
Okay, okay,
You
okay.
just need to write one Java code or maybe Python code, whatever coding language you use there. Okay, so that you can use. You can write your code. You can process your data set there. Okay, you can run your code in your this system laptop only. They will use their server for the processing.
Oh,
Okay,
that's great.
and
That's
at the
great.
end you will get the output.
That's great piece of information, Professor
Yeah.
Saran, from you.
Yes.
We can get past data also, means
Yes, past
environmental
data,
data,
whatever. Yeah, so
meteorological
whatever
data.
data set we have, like there are multiple satellites, those are available, and those provide data free of cost. Everything available there. So, for example, Landsat is one of the important mission in early 1970s or 80s. Okay, so you will get data from 1978 or something for the Landsat satellite. Okay, so similarly, there are number of satellites, those are very old. You can get data from this platform, Google Earth Engine. You don't need to put extra effort there to write a code also. If you search there a data product, it will also help you how to read that data, how to access that data. They have developed that system very simple and efficient. You can easily use it. And there are number of uh, tutorials, video sessions available on YouTube. You can easily watch those videos and learn Google Earth Engine.
Okay, thank you.
Okay, thank you, sir.
Definitely, sir.
Okay.
So, anyone else who would like to post any question? I think that's finished from the audience side. So, thank you, Dr. Shranada, for sharing your time and expertise at very short notice. Yesterday only you were informed and you accepted it at the very first call. We are highly thankful to you for your kind gesture because Professor Deepak Swami had some engagements and because of his visit, he couldn't took this lecture and you accepted this lecture voluntarily on very short notice. We are heartily thankful to you for this gesture and your presentation today. Since I'm also from Jodhpur, we both are from Jodhpur, working in Jodhpur. So specifically highlighting the digital twin for Jodhpur city, I'm really very I'm impressed and very happy that something is being done for my Jodhpur city also. And very specifically, you highlighted the key points of the digital twins and how by the videos you have shown how means like theory is one part, but when we see that video now, that really it was really very impressive to get the things understood well. So thank you, Professor Saran. We hope that in future also we'll keep having your services, and we too hope that you will extend your services for the benefit of the society, for the benefit of the academic world. Thank you very much, Professor Saran.
Thank you everyone. Thank you Kamlesh ji and Professor Kiran for inviting me for this FTP program. So if you have any question, you can write to me, you can contact me. Here is my email address and contact number. So if you have any doubt related to remote sensing hydrology, you can email me. If you have any doubt related to AI or transportation or anything, you can also write me, but I will forward your email to concerned person. They will contact you.
And Dr. Sharan, Dr. Pradeep is my student.
Okay, okay.
Dr.
Oh,
Rajlakshmi
nice,
is my
nice.
student.
Oh,
They both
nice
are my
to
students.
hear this. Oh, yeah.
Yeah, yeah, thank you.
Oh, yeah.
So I
Thank
think
you,
that these
Professor
lectures are
Srinath.
also a platform to meet our old students, our old friends, old colleagues. So it is an additional benefit that we get from these FDPs.
Oh, okay, thank you, everyone.
Thank you, sir. Thank you
Yeah.
very much.
Thank you, everyone. We'll take a break of 10 minutes till Professor Sanjay Mehta joins for the next session. We'll start at 7:30. Please be in touch and don't leave the meeting. Be there. Thank you. Thank you, everyone. You can all have a coffee and tea.
Good evening, Sanjay sir.
Good evening.
Sanjay sir. So it's 7:29. After 1 minute, we will start the next session.
In the meantime, it is to inform to all the participants that I have circulated a Google form today. You can fill your 4 days of attendance. You can mark your 4 days of attendance in that Google form, and please do not panic for the attendance. Actually, the attendance that we are receiving from Google Meet, the names that we are receiving, they are much different. The email IDs are also different from the registered one. So it was very difficult to figure out and to match the different names. So that's why we have again resumed to the old school of thoughts of circulating the Google form and collecting the attendance. So for the 4 days of attendance, I have circulated the Google form, and for next 2 days also, I will circulate the attendance Google form so that we can upload. And while uploading the attendance also, single attendance we require for to click 4 times. So it is very difficult to mark the attendance day by day. For 4 days of attendance, we'll mark tomorrow. So all the 4 days of attendance will mark tomorrow, and for remaining 2 days, we'll mark at the end of 6th day. So please do not panic about the attendance. You fill the Google form, and if you fill the Google form, just be confirm and be assured that your attendance has been marked.
So we are going to start the eighth session of this FDP on AI in disaster management and early warning system by Engineer Sanjay Mehta sir. And now no need to give any introduction as all are know about Sanjay Mehta sir. So please, sir, mic is over to you, sir.
Thank you, ma'am. Thanks a lot. Screen is visible to you?
Yes, sir.
Yes, sir, it's visible, sir.
Okay. Hello, everyone. Today's topic is AI in disaster management and early warning systems. As we know, the subject that is on the intelligence and disaster management and the warning systems. So we can proceed now. Okay. Hello.
Yes, sir, you may proceed.
Okay.
कुछ time पहले दिया था.
I had just given that everyone has the people are nothing right or wrong. Thus, they have different views of things as we have the different perspective angles in our engineering drawings. And according to we frame our perspective and the vision. So please let us start. What is a disaster? Is one thing before start. I can just brief summarize the abstract just like that. We can start up with the disaster management, its history, and what about this animal instincts, then AI system with the disaster system, and early warning signs, and few examples. So we are starting with the disaster management, the basics roots. The disaster is a sudden catastrophic event that causes widespread damage, loss of life, and disruption to communities, economies, and environment. Disaster can be natural or human induced and can take many forms. What is the disaster management? Disaster management is the process of preparing for, responding to, and recovering from disasters. It involves a comprehensive approach to reducing the risk and impact of disasters on communities, economies, and environments. Phases of disaster management it may be prevention, preparedness, response, recovery, and the mitigations. In the preventions, we have to taking measures to prevent disaster from occurring, such as enforcing building codes, conducting regular maintenance, and implementing safety protocols. The speed is okay. Preparedness for
Yes, sir.
potential preparing for a potential disaster by developing emergency plans, conducting drills, and stockpiling resources. What about response? The responding to a disaster by providing emergency assistance, search and rescue operation, and initial relief efforts. This is just in a cycle that recovering from a disaster by rebuilding infrastructure, restoring services, and supporting affected communities. What about the mitigations? Reducing the risk and impact of disaster by implementing measures such as flood control structures, earthquake resistant constructions, and the wildfire prevention programs. Now, what is the disaster cycle? Basically, is preparation, mitigation, response, and recovery. Few are after events and few are before events. There are mitigation preparations are the before events, and response and recovery is after events. Now we can proceed further. As a key component of disaster management, key component of disaster management are risk assessment, emergency planning, communication, resource management, and community engagement. I am taking these subjects on very brief, but I'm giving just the points, and we can discuss later. And sometimes you can have the detailing also of these particular points in the very vast level. The risk assessment is identifying potential hazards and assessing the likelihood and potential impact of disasters. Emergency planning, developing plans and procedures for responding to disasters. Communication, coordinating and sharing information among stakeholders, including the public, emergency responders, and government agencies. Resource management, managing resources, including personal equipment and supplies to support disaster response and recovery efforts. What about the community engagements? Engaging with the community to raise awareness, promote preparedness, and support recovery efforts. These are the key component basically. And what are the goal of a disaster management? Save lives, protect human lives, and prevent injuries, reduce damage, minimize damage to infrastructure, property, and the environment, support recovery, facilitate recovery efforts, and support affected communities, promote resilience, enhance community resilience, and reduce the risk of the future disasters. What are the type of disasters? There are many disasters. There are natural disasters, some are human-induced disasters, some are environmental disasters, biological disaster, and the technological disaster. There's a different shapes. Sometimes we says मुसीबत किसी भी रूप में आ सकती है, बहुत से रूप हैं इसके, और ये आपदा भले earthquake, hurricanes, floods, landslides, tsunami, volcanic eruption, and the wildfire. These are the natural disasters. Human-induced disasters, it may be the industrial accidents, nuclear meltdowns, transportation accidents, and the terror attacks. These are basic fundamentals of the disaster management, which we are discussing right now. And as and when we proceed further, we are going to the advancement about the artificial intelligence. As an environmental disaster, oil spills, chemical leaks, pollution-related disaster, as just recently we seen in the Jaipur-Bagroda roads, the oil spills and the gas spills out and all burns. As in the biological disaster, pandemics, just like coronavirus, epidemics, biological attach, geobiology, geopathic stresses, technological disasters, just like a cyber attacks, data breaches, technological features. These all factors can be explained in very described way, but we will discuss few of them, just like an earthquake, hurricanes. As an earthquake, because we know each and everything about the basics of this fundamental earthquake, seismic zones, and everything. The earthquake early warning system use earthquake signs and the technology of monitoring system to alert device and people when shaking waves generated by an earthquake are expected to arrive at their locations. For this purpose, USA, California developed a machine called Shake Alert, which gives the exact time of arrival of shaking to the stations. With the help of this technology, we can save so many lives and also reduce damage to building to some extent. This can be done by detecting the first energy to radiate from an earthquake, the P wave energy, which rarely causes damages. Using P wave information, we first estimate the location and the magnitude of the earthquake. Then the anticipated ground shaking across the region to be affected is estimated and warning is provided to local population. The method can provide warning before the S waves arises, bringing the stroke shaking that usually causes most of the damages. A user receives a message like this on the screen of this computer. The message alerts the user to how many seconds before the shaking waves arrive at their location and the expecting intensity of shaking. As this warning messages also display a map with the location of the epicenters, the magnitude of the quake, and the current position of the P and S waves. On our screen, shaken the real-time tracking of shaking wave from quake epicenter, real-time tracking of the fault ruptures, your current location, tracked by GPS, second remaining before seismic waves, intensity scales, and many things. Earthquake warning, early warning basics are they are just like an earthquake rupturing fault, sends out different types of waves. The fast-moving P wave is first to arrive, but damage is caused by the slower S waves and later arriving surface waves. As you seen in this figure, the sensors detecting the P wave and immediately transmit data to an earthquake alert centers where the location and size of the quakes are determined and updated as more data become available. A message from the alert center is immediately transmitted to your computer or mobile phone, which calculates the expected intensity and arrival time of shaking of your location. Another factor is the flood. A typical flood warning system includes a number of items, including automated sensors, which are placed at or beside river and reservoirs throughout the designated area. A data is then collected and sent immediately to a base station or a personal computer. In this way, appropriate forecasts are sent to authorities or communities of those potentially affected by developing flood as soon as possible. Detected meteorological monitoring, forecast meteorological monitoring, flood warning. They are just like thresholds when the warning in this nation issuing warning to the affected populations. And the response is that the continuous planning, recovery, repair, and cleanup operations, care for victims, review the can the system be improved, preparedness, emergency planning, public awareness, etc. Flood due to melting of ice. The community-based flood early warning system is used in Hindu Kush Himalaya, which is one of the most dynamic and complex mountain system in the world. It is extremely fragile, sensitive to the effect of climate change. One of the effects of climate change is the formation of melt lake on the lower section of glacier in Himalayan regions. Because such lakes are inherently unstable and subject to catastrophic floods, surges, they are potential sources of danger to people and property in the valley below them. The solution is what? The wireless system manages flood or flash flood, which does by providing early warning to downstream communities and enhances cooperation between upstream and downstream communities in the share of flood information. This solution considers two units, the transmitters and the receivers, which you see in the figures next. A flood sensor attached to the transmitter detects receiving water level. When the water reaches a critical level, a single signal is wirelessly transmitted to the receivers. The flood warning is then transmitted by mobile phone to concerned agencies and vulnerable communities downstream. Critical flood levels are set with the help of the local community. As we see in this drawing, community-based flood early warning system, which is receiver, transmitter, both are both are erected and they are connected with the village nearby. And the flood warning is distributed across different channels to communities and agencies downstream. The warning system consists of sensors that wirelessly transmit information about river water level to a receiver. This is the basic fundamentals which we are using right now. Then transmitters and the receivers, they are just like this. Early warning systems. Then working with TWS network of seismic monitoring station at sea floor detected presence of earthquake. Seismic monitoring station determine local depth earthquake having potential to cause tsunamis. Any resulting tsunamis are verified by sea level monitoring stars such as Dart Buoy and Tidal Buoy. Detectors, coast tidal gauges measure sea level near coastal area, continuous monitor and confirming tsunami waves following an earthquake. If tsunami occurred other than earthquake, we depend solely on the data of tidal gauge. There's a dart buoy. Report to Tsunami Warning Center. When tsunami occurs, information are processed to produce a new and more refined estimated tsunami source. Results in an accurate forecast of tsunami. Working of dart buoy consists of two main components, bottom pressure recorder and the surface buoy. BPR consisting of modem to transmit data to surface buoy and surface buoy data warning center by satellite communication. Bottom pressure recorder. These all are equipment early we are using right now using dizzy quartz broadbands depend sensor in the main sensing elements. Just like the surface buoy makes satellite communication to warning center, they will use the thread and issue in the tsunami warnings. They are just diagram of the dart buoy, how we are using this deep ocean assessment and reporting of tsunami, acoustic transducer and the system with the satellite. How this is a tsunameter is working with the acoustic telemeter and acoustic transmitter to the surface buoy and then goes to satellite and goes to tsunami warning centers. What about cyclone? Early detection of TC would be beneficial in many areas. Would give the public more time to prepare for a potential future threat. Early detection allow scientists more time to plan research missions into storms. In research application, it also allows the study of determining what promotes tropical cyclogenesis. The detection algorithm described here is based on the vorticity. Cyclone scatterometers are unique among satellite remote sensors in their ability to determine surface speed and directions. Microwaves are scattered by short wave water waves, capillaries, ultra-gravity waves. They respond quickly to change in winds. The back scatters cross section, the fraction of transmitted energy that returns to the satellite is a function of wind speed and wind direction relative to the orientation of the scatterometers. What scatterometer actually determines equivalent neutral wind speeds at a height of 10 meter above the local mean water surface, which differs from the wind speed that would be measured by anemometer after adjustment to a height of 10 meter. That is known. This is the photograph of the scatterometer, the sea wind scatterometer. You see with the connected with the satellites for the cyclones. Cyclones have their water city field example from ascending swath on 19th September. Water city is the calculated from the scatterometers as we seen and discussed. Tropical cyclone distribution worldwide as is seen in this distribution is near the equator and above and below. How these agencies are for forecasting and who agencies works in India. Disaster cyclone is coordinated and maintained by Indian Meteorological Department. Tsunami is by Indian National Center for Oceanic Information right now with services. Flood is with Central Water Commission and earthquakes in Indian Meteorological Departments. And the international agencies and organizations which are working for all these disasters is the FEMA recovery programs, National Disasters Management Authority of India, the International Recovery Platform, World Conference on Disaster Reduction, International Study for Disaster Reduction, the Red Cross, Voluntary Relief Organization, the World Food Program, the WHO, United Nations, UNESCO, and the European Unions, and several many more. They are working on this disaster management. Characteristics of disasters. There are several characteristics, but the suddenness, that is a disaster, often occur with little to no warning. तुरंत आ जाना, एकदम अचानक ही विपदा आ जाना. Severity. Disasters can cause significant damages, loss of life, and disruption. Uncertainty. Disaster can be unpredictable and uncertain in their impact. Impact is disasters can affect individual, community, economies, and environment. Effect of disasters, humanitarian, loss of life, injury, displacement, and trauma. Psychological trauma, economic damage to infrastructure, loss of property, and disruption to businesses. Environmental damages to ecosystem, pollution and loss of biodiversity, social disruption to community, social structures, and cultural heritage. History of disaster management. In the very ancient civilization, 3000 BC and 500 C, we see the flood control. The ancient Mesopotamian built levees and canals to control flooding. As earthquake resistant construction, ancient Greeks and Romans developed building code and construction technique to withstand earthquakes. Disaster relief. Ancient Chinese emperor provided relief to affected populations after disaster. In the Middle Ages and 500 to 1500 C, church-based relief. Christian churches play a significant role in providing disaster relief. Guilds and mutual aids. Craft guilds and community organizations provided mutual aid and support during disasters. In the modern era, the National Disaster Relief Government begins to take a more active role in disaster relief with the establishment of national relief funds, development of emergency services, fire department, ambulance services, and the police force emerged to respond to disasters. In the 20th century, international cooperation, the United Nations, the international organization began to play a significant role in the disaster management. Development of disaster management agencies, national disaster management agencies such as FEMA in the United States were established. Advances in technology, improved communication, transportation, and construction technology enhanced disaster management capabilities. In the 21st century, increased focus on disaster risk reduction. The international community has emphasized the importance of disaster risk reduction and mitigation. Advances in ICT and data analytics, improved data collection, analysis, and dissemination have enhanced disaster management decision making. Growing recognition of climate change, the impact of climate change and disaster risk has become a major concern, driving effort to reduce greenhouse gas emissions and adapt to changing climate conditions. Use of artificial intelligence we are using in the 21st century right now. As we see in the early age, how we can detect the disasters pre-occurrence, it by the human intuitions or by the animal intuitions. Animal instinct are the main super senses in the animals, which they are capable, how they are working. अगर हम जाते हैं इतिहास में, अगर देखते हैं तो जानवर, पक्षी और इनके थ्रू हम देखते हैं कि इनकी चाल, इनके हाव भाव हम चेंज कर देते हैं कि किस तरह से एक डॉग है या चिड़िया है, चींटी है, इनकी एक्टिविटीज चेंज हो जाती है इन अदर डिफरेंट टाइप्स ऑफ डिजास्टर्स मैनेजमेंट्स के अंदर. अगर हम देखते हैं दे आर जस्ट लाइक ईगल. ईगल जस्ट इन द प्लेग्राउंड फ्लू डाउन एंड टुक अवे योर रोटी. ईगल का जो विजन है वो 4 मीटर से 5 मीटर तक वो एट अ टाइम देखता है, पर हम लोग जो ह्यूमन बॉडी है 2 मीटर 3 मीटर तक हम क्लियरली देख सकते हैं. इसी तरह से डॉग्स हैं, अगर हम पास में से निकले तो उसके कान खड़े हो जाते हैं. एज यू वॉक सॉफ्टली पास स्लीपिंग डॉग, इट ईयर शाउट अप एट वंस. और इसकी इंट्यूशन और स्मेलिंग कैपेसिटी बहुत अच्छी होती है. इसी तरह से जो सिल्क मॉम है वो अपनी स्मेल से देख सकता है. चींटियां हैं, उनको अपना जो है कलेक्टेड अराउंड जो भी ड्रॉपलेट्स डालते हैं वो तुरंत इकट्ठी हो जाती है. यू ड्रॉप समथिंग स्वीट्स ऑन द ग्राउंड, विद इन मिनट्स मैनी एंड्स कलेक्टेड अराउंड इट. तो इनका जो मैनेजमेंट है वो देखने लायक होता है. और इसके इंट्यूशन से हम देख सकते हैं कि कभी बारिश का, कभी साइक्लोन का, कभी सोलर इक्लिप्स का, तो कभी अर्थक्वेक्स का. दे हैव ऑल द इनिशियल इंट्यूशंस and that instincts we can use it in our olden times. Why does it happen? Things and tell. Different senses they can see, hear, taste, smell, and the feel. Some animal can see their prey from far away. Some can hear even the finest sound. Some animal can find their friends by their smell. The animal world is full of example of amazing senses. Have you seen a dog sniffing here and there? What do you think? It is a try to smell dogs? No, it's making the area on the roads. The same thing is, as scientists did many experiments like this and found that when the ants move, they leave a smell on the ground. The other ants follow the same smell to find the way. Now, can you guess why the ants behave like that? When they block their path, some male instinct can recognize the female by their smell. Troubled by mosquitoes, just like how they know where you are. Mosquitoes can find you by the smell of your body. They also find you by the smell of the sole of your feet and the heat of your body. They are just like animals are vulnerable, instinctive, and learning being in the field of the dust management. A comparative perspective is there. The hour before giant waves pounded coastline in South Asia, many animals started behaving strangely. In Sri Lanka, elephant is trumpeted frenetically and fled to high ground bats, and flamingo deserted low-lying areas. Many other animals escaped unharmed. Wildlife experts are amazing that many animals survived the tsunami. The series of huge waves killed thousands of people in South Asia and Africa. In 2004, experts say animals mightly have sensed the approaching waves and moved to high ground. Scientists say that elephant can pick up vibration from earthquake through their broad feet. Elephant nails are in the skins and not attached to the toes. Elephant soles have sensitive foot pads that detect vibrations such as those from an earthquake that signals elephants to move and to more stable grounds. As we are proceeding, there is the early warning sound system is working, just as see with the animal instincts. And the early warning system can be defined as a set of capacities needed to generate and disseminate timely and meaningful warning information of the possible extreme events or disaster. Example: flood, drought, fire, earthquake, and tsunami that threaten people's life. The purpose of this information is to enable individuals, communities, and organizations threatened to prepare and act appropriately in insufficient time to reduce the possibility of harm, loss, or risk. Characteristics of early warning signs. Affects early warning system requires strong technical foundations and good knowledge of the risk, but they must be strong people centered with clear messages, dissemination systems, public awareness, and educations are critical. In addition, many sectors must be involved. Effective early warning system must be embedded in the understandable manner and relevant to the community which they serve. Three phases of early warning system are there. Forecast indicate catastrophic events, then measurement of precursors and the warning. As and when the measurement of precursors, forecast indicate warning, and one set of the anticipated response also in the system. Now we are proceeding toward the artificial intelligence and the disaster management correlation. Can machine think? अभी तक तो हमने मशीन से काम करवाया था, क्या हम मशीन सोचने भी लग गई है? क्या आर्टिफिशियल इंटेलिजेंट का मतलब ये है कि अब मानव का जो ब्रेन काम करता था वो मशीनें काम करना शुरू कर देगी? दिस इज द फंडामेंटल द क्वेश्चन अराइजेज इन द माइंड कि क्या अब वही सब काम करेगी तो हमें कुछ करना नहीं पड़ेगा? तो आज देखते हैं एआई का क्या रोल है इसके अंदर डिजास्टर मैनेजमेंट के साथ में. What is AI? AI stands for artificial intelligence. It encompasses the simulation of human intelligence processes by machines, particularly computer systems, which includes learning, reasoning, and self-correction. In disaster management, AI applies these processes to analyze complex data, make logical predictions, thereby enhancing operational effectiveness in crisis situations. Role of AI in disaster management. Artificial intelligence play a pivotal role in disaster management by improving response time, optimizing resource allocation, and enhancing the accuracy of predictions by processing vast data sets and identified patterns. AI system can inform strategic decisions that ultimately save lives and minimum damages. Early warning system leverage a variety of technologies and data sources to detect the anticipate disasters. Integrating AI into the system allows for the automation of alert and the generation of more precise forecasts, providing communities with the vital information to prepare for implementing threats. The purpose is that artificial intelligence technology is an innovative approach that can be developed to enable rapid and effective action in disaster management activities for disaster affected countries. This study aimed to reveal the role and application method of artificial intelligence system in disaster management processes pre and post disaster. It also discussed the adequacy and effectiveness of these role and method, especially in the Turkey as we see. Study design, methodology, and approach. We have the systematic literature review on the use of the AI system in disaster management conducted, and inventory on the use of AI disaster management developed. This inventory was prepared by considering earthquake, flood, fire, tsunami, hurricanes as data sets. These data sets are categorized, compared, and evaluated in the term of their application locations, time and duration of use, pre or post disaster. Developed AI system and this proposes method, scale, and final products. The finding is that the study reveals that the use of AI system will be effective in minimizing logical challenges in the intervention and the management of natural disaster. Additionally, the systematic review has observed a frequent focus on earthquake in applications related to disaster, and it would determine that the reach on the prevention process management of other potential disaster is limited. originality and the value. The study is highly effective in revealing the role of AI system in disaster management, identifying their utilization in Turkey. It is expected to provide preliminary knowledge for future studies by focusing on artificial intelligence studies in disaster management in a holistic manner. Historical disasters have become a significant risk factor for humanity. Destructive consequences caused by both natural processes and human activities are observed on a global scale. The actual data and simulated data required for these data-driven systems are generated consciously or unconsciously throughout the day. Advanced information communication technologies such as social media, telecommunication data, and remote sensing make large amount of actual data available. Recent advances in artificial intelligence, machine learning, and deep learning have actively used to deal more effectively with the severe and often devastating impact of disaster using such data. Pre-disaster phase. Risk assessment and prediction. AI analyzes historical data, weather patterns, geological information to predict the likelihood and potential impact of disasters. Vulnerability mapping. AI-powered map identify areas prone to disaster, helping authorities prioritize resources and evacuation plans. Emergency planning and preparedness. AI assistant in developing response plans, conducting simulations, and identifying potential bottlenecks. During the disaster, how the AI work, the real-time monitoring and situational awareness. AI-powered sensors and drones proved real-time data on disaster progression, helping responders make informed decisions. Damage assessment and need analysis. AI quickly assesses damages, identify areas of need, and prioritize the resources allocation. Search and rescue operation. AI-powered drones and robots aid in locating survivor, navigating rubber, and detecting hazards. Post-disaster phase. Relief and recovery effort. AI optimizes resources allocation, streamline logistics, and facilitates communication between response team, damage assessment, and reconstruction planning. AI analyzes data to identify areas for reconstruction, prioritizing rebuilding effects, and optimizing resource allocations. Long-term recovery and resilience buildings. AI-informed policy decisions, identifies areas for infrastructure improvements, and supports community resilience building initiatives. These are the pre-post disaster phases, and now the AI technology used in disaster management. There are many machine learnings, analysis data pattern to predict disaster, assess damage, and optimize response efforts. Natural language processing. NLP, that enables AI in system to understand and respond to emergency calls, social media posts, and other text-based data. Computer vision analyzes images and video from drones, satellites, and other sources to assess damages, detect hazards, and identify area of need. Geographic information system provides spatial analysis and mapping capabilities to support disaster response and recovery efforts. Benefit of AI in disaster management. What are the benefits we have understanding? Just enhance situational awareness. AI provides real-time insights, enabling responders to make informed decisions. Improved response time. AI optimizes resource allocation, reduces response time, and saving lives. Increased efficiency. AI automate tasks, streamline processes, and reduces the workload of response team. Better decision making. AI analyzes data, identifies pattern, and provides predictive insight supporting data-driven decision making. Challenges and limitations. Data quality and availability. AI relies on high quality, relevant data which may not always be available. Collection of reliable data is very important in the system, and interoperability and integration. AI system may not integrate seamlessly with existing infrastructure, requiring additional development and testing. Explainability and transparency. AI decision-making process may be opaque, making it challenging to understand and trust AI-driven insights. Ethic and bias. AI system may perpetuate existing bias or introduce a new one, requiring careful consideration and mitigation strategies. Future direction. Increase investment in AI research and development. Government and organizations should invest in AI research to improve disaster management, development of AI specific standards and guidelines. Establishing standards and guidelines for AI in disaster management will ensure interoperability, safety, and efficacy. Enhanced collaboration and information sharing, encouraging collaboration and information sharing between the government, organization, and communities will improve AI-driven disaster management efforts. Addressing ethics and bias concern, developing and implementing strategies to address ethics and bias concern will ensure that AI systems are fair, transparent, and trustworthy. That is known as future directions. Just as see, the globally we can use the AI in this test responses. The disaster management cycle is just like a recovery, mitigations, early warnings, impact, and emergency response. Just this is basically disaster management cycle. And as we discussed before disaster, during disaster, and after a disaster, that is mitigation. The develop, prevent law and regulations, implement advanced code and standards, establishing zoning requirements, buy insurance, construct barriers as a mitigation. Preparedness is stock disaster, supply kits, devote mutual and aid agreements and plans, train response personnel and concerned citizens, prepare shelters and backup facilities. They are before a disaster. During a disaster response, search and rescue to identify affected people, assess initial damages, provide first aid and humanitarian assistance, open and manage shelters. After a disaster, debris removal, precise damage assessment, infrastructure destruction and reconstruction, restore the livelihood, community development. Application of artificial intelligence disaster management, as you see in this list, this is too long. That is in the phases the mitigation, preparedness, response, and the recovery. Before, at the time of disaster, and the after. These are artificial intelligence methods, so the linear regressions, non-linear regressions, logistic regressions, support vector machines, Navier, and these all are the applications which we are using day to day right now in different fields of the artificial intelligence, particular science and simulating analysis. Methodology. The study aims to evaluate the use of artificial intelligence disaster management in Turkey by identifying the studies related to disaster management and the use of artificial intelligence, and the research process was methodologically considered in 5 stages. इसको 5 फेजेस में डिवाइड किया गया है डिजास्टर मैनेजमेंट जस्ट लाइक दिस आर्टिफिशियल इंटेलिजेंस दिस मशीन लर्निंग डीप लर्निंग इमेज प्रोसेसिंग systematic literature review the disaster type, time of use, place of use, method, result, product. The bibliographic analysis. Bibliographic analysis in disaster management and after AI coming in disaster management, researches and keywords. In artificial intelligence used effectively in disaster management, advantage and disadvantage studies in the literature, regions where the artificial intelligence is used in disaster management, how artificial intelligence is used in disaster management, the place of artificial intelligence in disaster management in Turkey. And last we come to the conclusion. This is step 1 is disaster management, step 2 is artificial intelligence, systematic literature review, third step, bibliographic and evaluation and the discussion, and last is conclusion. The main process in disaster management discussed in the first step, and the place of artificial intelligence in the disaster management process was defined. In the second step, the background of artificial intelligence system and the uses area in disaster management was focused. Then the existing studies in the literature were reviewed in order to make the evaluation on this use in Turkey. The review required a systematic process to be followed. Disaster management, a systematic literature review and assessment examine all studies that can be related to a given topic in order to answer a specific problem. This method involves a gradual literature review, filtering the result of the review, critical analysis of the studies, assessing the quality and the level of evidence, interpretive analysis of the findings, and reporting for the intended audience. In this context, the systematic literature review was conducted in the third step of the study. In the fourth step, bibliographic and metric analysis was conducted to reveal the relationship between the process monitoring and the studies conducted in the field. Background of the disaster management and the AI system. From the past to the present, they have various disasters that have caused significant losses worldwide, and these disasters are still continuing. Since most disasters occur in a very short period of time, rapid planning, decision making, and implementation of the right practices are critical for successful and effective disaster management processes. In general, the disaster management process has a complex and dynamic structure. There is a risk reduction, hazard and risk maps, risk mitigation plan, risk and loss scenario, heritage protection, alignment with sustainable development, establishment of disaster information bank, Then the preparedness and planning, education, awareness, rising legislation, development of disaster volunteerism, improving emergency communication and infrastructure in disaster. Intervention, national and international disaster response plan, effective response technology, early warning and damage estimation systems, and rescue and remediation. Standards of damage estimation, national and international disaster recovery plan. This is the background of disaster management AI system. We can use the application of AI in many fields. They are just like healthcare, training, finance, trade, energy transport, entertainment, and the media. Personalized content like recommendations, movie, music, books, AI characters in the games, automation, generation of medical media contents, agriculture, the harvest forecast, disease and pest detections, automatic irrigation systems, production and industries, machine learning and researches, learning, customer services, security, real estate. These are the application from where we use AI right now. And method of using AI in disaster management, disaster forecasting and early warnings. हम लोग एआई जो है बहुत से डिफरेंट सेक्टर्स में ले सकते हैं. मेथड ऑफ यूजिंग एआई इन द डिजास्टर मैनेजमेंट, एआई algorithm can predict natural disasters such as hurricanes, earthquake, flood by analyzing weather information, seismic activity, other related factors. These forecasts aid local residents and authorities in enhancing their preparation for disaster. Damage assessments. Drone or satellite imagery can quickly survey the post-disaster area, and AI can analyze these images to provide information on the extent and severity of damages. This can help determine where to direct relief resources most effectively. Logistic and resources management. AI can be used to optimize disaster relief resources and logistics. It can analyze data to determine which regions need to most urgent assistance and how to distribute resources most effectively. Public communication and information. Chatbots and other AI applications can be used to provide up to data information, answers frequently asked questions, and provide guidance to disaster victims and communities. Disaster risk assessment. AI can assess the future disaster risk of a given region based on historical data. This can help make informed decisions in the urban planning and infrastructure investment. Training and simulation. AI-enabled simulations can be used to prepare disaster responses. For a real disaster scenario, these simulations allow teams to test and improve their response strategies. Post-disaster recovery, AI can help prioritize post-disaster infrastructure repair, allocate resources, and help communities recover faster. आर्टिफिशियल इंटेलिजेंस के टूल्स, एप्लीकेशन एग्जांपल्स एंड एप्लीकेशन एरिया हम लोग कहाँ कहाँ काम ले सकते हैं. दे आर जस्ट लाइक डिप शेक. डिप शेक is developed in the Stanford University and used for the seismic analysis and is risk hazardous and determine zoning requirements. इसी तरह से the flood forecasting, RCFX, XVI2, MICOS, these all are the right now the tools. IBM research and the Google and many are working on these more and more precise. Some are used before disaster, some are used for during disaster and after disaster. The same thing as and when see is the mitigation, preparation, response, and the recovery. And these are the tools we are using in the different for RCFX. They are just like the Watson and artificial intelligence system developed by IBM Research AIM. These are also a tool. Predict volcanic eruption. This AI analysis aim to create a realistic simulation as a result of combining advanced algorithm, computing, and big data from sensor and the Internet of Things. These are the tools which we just recently discussed. This is developed by IBM. As a deep learning based system, the hurricane disaster prevention, preparedness, and early warning was created in conjunction with an artificial intelligence analysis system supported by NASA and development seed. The deep learning based hurricane intensity predictor is an experimental framework that explored the application of artificial intelligence technologies and cloud computing resources to provide automatic and accurate prediction of tropical cyclone intensity. Byte Defense, aviation and space technology have developed the earthquake and emergency simulation application used in disaster management in Turkey. In this system, it is aimed to create realistic scenario by evaluating the effect of environment, infrastructure, population, and actors involved in the scenario. XV2, which provide damage assessment study on 6 disaster types, use satellite images of nature disaster in a machine learning data system, and there are many, 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 as we see in the list, which is used for the different purpose in disaster management as a tool. Now we see the multidimensional seismic risk assessment, combining structural damage. These tools, how we are using in the earthquake or seismic areas, the risk assessments and the product by a seismic event. As we see in this photograph, the two dimensional of damages, they are the two damages, the structural damages and the psychological consequences produced by a seismic event, in which the depression, anxiety, and the post-traumatic stress disorders also developed in the habitats. Seismic is an evaluation of probability of the damages, losses produced by potential seismic events. As we see the multidimensional risk assessment combining structural damages in psychological consequences using explainable artificial intelligence. As this is a class of structure, representative benchmark structures, representative benchmark families, and the structure analysis and the structural damages, and the class of families with the psychological analysis and psychological consequences, the real structure and families, expect seismic action, and XAI to establish similar criteria. Risk assessment including structural damages and loss and psychological consequences. As we discussed, the bibliometric analysis of keywords in studies on disaster management. In the disaster management, these are the key areas which we are seeing in the patterns as look the remote sensing, social media, resilience, climate change, deep learning. They all are part and part of this bibliographic analysis, and how we compare with after the coming of the AI. AI के आने के बाद में bibliographic analysis change हो गया, and the remote sensing, deep learning technology that can associate with disaster, they are compiled and more precise by the years. As AI and disaster management were examined, the first of the studies containing the keyword artificial intelligence in disaster management was published in 1996, and now it's 2025, which we are in the using this. A number of publications as we use in disaster management artificial intelligence are more and disaster mitigation artificial intelligence, disaster preparedness. This is seen in the graph you see. A mysterious energy disaster inside and around us. As we discussed, this is basically disaster management के साथ में हम लोग we are entering in this energy disaster inside out. As we discussed yesterday, the mysterious energy disaster inside and around us. हमारे आसपास में mysterious energy किस तरह से काम करती है और किस तरह से हम लोग वर्क कर रहे हैं इसके अंदर. And what is the geopathic stresses as discussed in yesterday? Suffering due to geopathic radiations. EMR and geopathic stress is common problem faced by individual and organization. From poor sleep quality to decreased productivity, these individual threats pose not one but many concerns that could adversely affect individual and work environment. This is also a modern threat which is developed right now with our energies inside and around us, which is disastrous. They are just like in the cell phone antenna and the antenna tower. They are the body scanner as discussed yesterday, and this is cell phone tower and the high tension lines which provide hazards, health hazards, and the 5G radiation, which is as discussed the alteration of heart rhythms and numerous several problems of the maybe the biological problem, maybe other problems, neurological damages, obesity, effect in children. They are non-ionizing radiations as discussed yesterday. Ionizing radiations, they are the different electromagnetic spectrums. They are just how the working is our the radio frequencies levels, different frequency levels. AC electrical field can be present even when electrical current not is flowing, dirty electricity, electro pollutions. We are now suffering and faces that's like a disasters. What is the EMR? Our more commonly used electronic devices, mobile phone, laptop, Wi-Fi, router, smart TVs, and they all are used at home or workplaces. Use radio wave for transmission. These radio waves generates radio frequency, radiations, and more commonly to known as electromagnetic radiations. EMR is a term that we normally associate with the massive mishaps in the history of mankind, like the Hiroshima Nagasaki bombing, China Boyle nuclear reactor disaster, and a few other incidents. However, not many of us realize that EMR is actually all around us, everywhere, every day, in the form of wireless or mobile radiation. These EMR emissions are unseen and hence are more dangerous with our exposure to small devices going up exponentially. We need to use technology responsibly. Environment offer unique solution to safeguard ourselves from the harmful effect of EMR. What is EMR exposure? Electromagnetic radiation is a term used for constant waves of electromagnetic field emanent from wireless communication devices such as mobile phone, computers, TVs. Basically, an incident when we come to in contact with the harmful E radiations, exposure to high radio frequency electromagnetic field can cause serious biological issues. Definition are static electric, static magnetic, and time varying electricity magnetic, electromagnetic radio wave field with frequency up to 300 gigahertz. Your health effect, you see the two categories of health effect, the thermal effect and the non-thermal effect. Field and frequency is static electric and 0 to 1 hertz. They are come in the criteria of the MRI machines, nuclear magnetic resonance, electromagnetic lifting cranes, electrochemical processes. Or as it is intermediate frequency field, they are just like 100 kHz to 100 megahertz. That is the surgical diathermy, anti-theft devices, military and radio frequency systems, broadcasting systems, and 100 to 300 at broadcasting TV antenna, radar, MRI, foils, anti-theft system. And last one is the 100 to 300. Economic electromagnetic radiation wake-up call for everyone. What is geopathic stress? Refer to the natural energizing emanating from the earth. The word is derived from the two Greek words. Geo means earth and pathos means disease, as discussed yesterday. Prolonged exposure to geopathic stress and imperishable health concerns, radiation, in particular detrimental to children and the elderly. It is also known as to affect the plant growth and cause a high breakdown in machines and industries. Laws around the world, the global laws on MR exposure, government authorities all over the globe are taking serious action on the issue of electromagnetic radiations. Does EMF go through walls? Yes. The low frequency radiation can penetrate anything that just go to straight. Therefore, wall cannot make the radiation bounce off. Hence, the EMF from the neighbor house can also affect you. You can use envelope chip to purify harmful radiation coming to you from outside inside the home. The damaging effect of EMR on individuals. In simple word, EMR can be locked at the electromagnetic waves. Radio waves have the longest wavelength in the electromagnetic spectrum. Gadgets including mobile phone and Wi-Fi routers use radio waves for wireless transmission. As yesterday, see the effect of the mobile phones. Is your home geopathic stress free? That creates the stress, fatigue, and backache in the body pains. In 1940, Ernst Herzmann, German scientist, geopathic radiations. He developed with the Anthony Bovis and the scientist about the different energy waves. Effect of geopathic radiations we can see in our offices and day-to-day life. How we disturb our life. Sleeplessness. It may be the higher attrition rate. Just like you see in the office staff, there are the three staff. The two is working very well, and the one is affected by the geopathic stresses. As higher attrition rate, he leaves the office, and always there is a problem with this particular table and the chair. Repeated machine breakdowns in the industries due to geopathic stresses. There are breakdowns, repeated machine breakdowns. ये breakdowns किस कारण से होते हैं कि geopathic stresses and there are the different problems created by the earth energy EMF radiations. Has 70-80 correlation with the repeated machine breakdowns, disharmony of parents, too high expectation, frequent criticism, vastu defects, and the brahmisthanam. These are created by the geopathic stresses. And the Australian government issues fact about the reducing exposure radiation from mobile phones. Finnish government authorities require children to limit the use of mobile phone. Belgium government banned cell phone and aimed at children younger than 14. A study by ICMR India found radiation harmful to the human health. And there are the different government, Israel government, it may be Swiss government, it may be the India or somewhere else in the world. WHO has compiled a whole laundry list of environmental factors. The Washington Post or Wi-Fi allergy is a real thing. A quick guide to electromagnetic hypersensitivity. These are the governments, they are using the restricted use of the cell phones. And we are still having tenders of the mobile towers in the on the roads and the nearby in the houses. These are the effect of the sleep disorder, heart health, brain health, absenteeism, low sperm count, ADHD, smart tradition affected memory, harmony of the parents, too high expectations, attritions, fatigue and stresses. They are this harmony many things. Accident prone zones are created by these are the geopathic stresses. They are just like in the black spot on the roads and the roadside the highest accidents created due to these things. And there are many disharmony in the families affected diverses cases, disharmony in the houses, studies, and many in the businesses. We all day to day we observe effect of debates. We have hypertension, anxiety, blood pressure, stress, depression created due to these radiations. Need peace of finance. You need financial peace basically. How I can reduce EMF in my home? You can reduce EMF in your home by minimizing the use of wireless communication devices and home appliances that emit radiation. Some examples are as follow: limit the use of microwave oven, put the smartphone, airplane mate, when it's speaker phone, when talking on mobile phone, keep all the radiation emitting gadgets away from your body, etc. Each layer of how healthy is your system based on science of building biology. Each layer of your working space affect each layer of your body. Most hazardous is the building defect is the toxic building materials, faulty design, electromagnetic radiation, and geopathic stresses. And the anatomy of the human body also is the part and part of it which is affected by these radiations. As we discussed, Paryar sir, yesterday there was a major importance of Lakshman Rekha in the Vastu Shastra. How these energy lines is created all around the by Lakshman in that time. The Lakshagrat, again the bad material uses affected, and how they affect the bad material disastrous for the human system. And with the invisible thread in your living and work spaces while you lead your life comfortably. ये वास्तु का पार्ट है जो मैं डिस्कस करने जा रहा हूँ आगे कि किस तरह से एनर्जीज और एनर्जी लेवल्स वर्क करती है और वो किस तरह से डिजास्टर्स भी हो सकती है अगर वो अलाइनमेंट और सिस्टम में नहीं होती है तो Vastu Shastra, how the Vastu works with the scientifically problem. This is my thesis in that time. And the ancient building laws, the Institute of Engineers Generals published as yesterday we discussed. These are the generals in 1956, 1955. The Feng Shui is working, the Vastu is working. The total energy through Vastu Shastra, as we discussed, how the human system works. That is the sleeping with the head toward east, north, south. Day to day, we understand the Vastu principles heard from every third persons. And the energy flow from inside to outside, then the door openings and the corrected slopes shape existence. How these energies work? ये energies काम कैसे करती है? किस तरह से दरवाजे का प्लैंक ऊपर नीचे होना चाहिए, दरवाजे अंदर खुलना चाहिए एनर्जी फ्लो के लिए, और इस तरह से दरवाजों के प्लैंक्स अप एंड डाउन होने चाहिए, या ओपनिंग्स ऑफ द डोर्स, मेन गेट पोजीशन, सेकेंडरी गेट पोजीशन, ये किस तरह से होनी चाहिए, क्लॉकवाइज एंटी क्लॉकवाइज स्टेयरकेसेस किस तरह से काम करती है. इसी काम करने के लिए क्या है कि दे हैव द एक सिस्टम क्रिएट किया गया वास्तु में कि पुरुष मंडला किस तरह से काम करता है. एंड एनर्जी ग्रिड्स, दीज आर द एनर्जी ग्रिड्स, हर्जमैन ग्रिड्स, they are developed in 1970s by the German scientist. The cardinal directions, the x-x axis, y-y axis, and the z-z axis. These axes are working like geobiology in the human system. हम लोग जब सवेरे से शाम तक काम करते हैं तो ये ह्यूमन एक्सेस होती है, एक्स एक्सिस, वाई एक्सिस, जेड एक्सिस, एज इट इज इन द बिल्डिंग एंड द बॉडी. एंड जो टाउन की है उसके अंदर एक्सेस होती है. जैसे ही ये एक्सेस अपनी जगह से शिफ्ट होती है तो ह्यूमन बॉडी जो है ये स्ट्रेसेस डेवलप करना शुरू कर देती है एंड डिस्टर्ब पोजीशन ऑफ एनर्जी एक्सेसेस डेवलप हो जाती है. और ये वापस जब अपनी जगह पे आती है तो आदमी स्ट्रेस फ्री हो जाता है. और इस तरह से क्या मेंटल, विटल, फिजिकल एंड साइकिक जोन 4 डिवीजन में ह्यूमन एनर्जी एक्सेसेस को डिवाइड किया गया है, जिसके अंदर मेंटल, विटल एंड फिजिकल और साइकिक जोन्स को किस तरह से हमारी एनर्जी एक्सेसेस के अंदर जो हमारे फिंगरप्रिंट्स में है वो बैलेंस कैसे करती है और कैसे इफेक्ट करती है. जैसे फ्रंटल एंड डोर्सल पोर्शंस हैं, 4 टाइप ऑफ एनर्जी एक्सेसेस ऑफ बॉडी है. दिस इज द लैकर एंटीना, हाउ टू चेक द एनर्जी. हम लोग एनर्जीज को किस तरह चेक करते हैं, ह्यूमन एक्सेसेस को इसको कैसे चेक कर सकते हैं. तो एंटीनो बोविस इज अ साइंटिस्ट हु डेवलप्ड दिस लेकर एंटीना टू चेक द एनर्जीज को चेक करने के लिए. नॉर्मल ह्यूमन बॉडी की जो एनर्जी लेवल है 6500, एक आम आदमी की जो हेल्दी है, अगर वो हेल्दी नहीं है तो उसकी एनर्जी लेवल्स डाउन हो जाती है. और अगर वो किस तरह से पॉजिटिव एनर्जीज को चार्ज कर सकता है, उसके लिए वी हैव क्रिएटेड मैनी थिंग्स जस्ट लाइक पूजा, ध्यान और अलग अलग एक्टिविटीज क्रिएट किए गए, जिसलिए मेडिटेशन अलग अलग काम करने के लिए. दे आर द हिंदू कॉन्सेप्ट. मुद्रास के अंदर जो है वो हमारे हेड जोन को अफेक्ट करता है. द टचिंग द थंब टू द निप ऑफ द फिंगर, ये मेंटल एक्सिस को हमारे को हेड जोन को क्रिएट करता है. ये हमारे ट्रंक जोन को अफेक्ट करती है, और इसी तरह से ये हमारे फिजिकल एक्सिस को करती है. लास्ट वन इज द होल दिस साइकिक जोन. इसी तरह लेकिन बीएम वेवलेंथ ऑफ द सेम ऑर्गन्स, हमारे हर ऑर्गन्स की अपनी अपनी एक वेवलेंथ्स हैं. रीडिंग ऑफ द लेकन एंटीना के वेवलेंथ किस तरह से काम करती है, लीवर, किडनी, लंग्स, ब्लैडर, थायराइड्स, ये अलग अलग एंटीनो बोविस हैज द एनर्जी ऑफ द बोविस, इसकी वेवलेंथ कितनी है और इसकी लेकर एंटीना के ऊपर क्या रीडिंग्स हैं, ये भी हम लोग इसको रेगुलर देखते हैं. फिर ये ह्यूमन एक्सिस किस तरह से, हमारा एक्स एक्सिस है, वाई और डॉर्सल, ये दोनों ही पार्ट में काम करता है. ये पार्ट मॉर्निंग सन टू इवनिंग तक एंड इवनिंग टू मॉर्निंग तक इनकी एक्टिविटीज चेंज हो जाती है एनर्जी ग्रेड्स की. और इसी एनर्जी ग्रेड जो मॉर्निंग टू इवनिंग और इवनिंग टू मॉर्निंग, इन्हीं के ऊपर जो ये कॉलम चार्ट जो हमारा जो शुभ और लाभ का जो चौकड़िया है, वो इसी के ऊपर वर्क करता है, इवनिंग टू मॉर्निंग एंड मॉर्निंग टू इवनिंग के ऊपर. तो जियोबायोलॉजी इज द मेन सब्जेक्ट इन द एंशिएंट टाइम. और ये फ्रीक्वेंसी वेवलेंथ इसी के ऊपर काम करती है हमारी जो चौकड़िया जो है, जिसको कॉलम चार्ट भी हम बोलते हैं. And the swastik has the 10 lakh of bovis energy. If feel negative and embarrassing, तो सब जगह हम इसको काम ले सकते हैं. इसी तरह से जो यूरोपियन कंट्रीज के अंदर या बाहर की साइड में इंस्टिंक्ट के अंदर क्या होता है कि हम लोग यहाँ पे कॉलोनाइजेशन या कोई भी काम करते हैं सिटी के अंदर, तो उस सिटी के अंदर क्या करते हैं कि हमने कहीं पे बिल्डिंग खड़ा कर देते हैं, पर वो सबसे पहले क्या करते हैं, एनिमल इंस्टिंक्ट्स को काम में लेते हैं, इनको छोड़ देते हैं. अगर वो वहाँ पे जाके अपना खान पान या इनकी जो एक्टिविटीज़ को वॉच करते हैं, अगर सही है तो ही वहाँ पे अपनी टाउनशिप या कॉलोनीज या बिल्डिंग्स बनाते हैं, जिससे क्या है कि वो प्रॉब्लम्स क्रिएट नहीं हो. दे आर जस्ट लाइक द एनिमल्स जो है, जैसे कि बिल्ली देख रहे हैं, ये नेगेटिव एनर्जीज के ऊपर अपने आप को रिचार्ज करती है. इसी तरह से जो है हॉर्सेज हैं और भी जो है बर्ड्स हैं, वो अपने आप पॉजिटिव एनर्जीज के ऊपर चार्ज करते हैं. दे आर जस्ट लाइक इन आवर शक्तिपीठ, जस्ट लाइक तिरुपति है, शालवासर बालाजी हैं, या और भी जैसे हैं खाटू श्याम जी हैं. तो ये हमारे पॉजिटिव पॉइंट्स हैं अर्थ के ऊपर, जहाँ हाईली पॉजिटिव अर्थ एनर्जीज डेवलप होती है, जहाँ से हमको अपने आप को रिचार्ज करके आते हैं. इससे से नेगेटिव इलेक्ट्रॉन डेवलपमेंट होती है, जो पूजा ध्यान हम लोग सिग्निफिकेंस के साथ करते हैं. और इसी के साथ साथ में अगर हम लोग हिटलर का या नेगेटिव देखते हैं, तो नेगेटिव है -10 लाख ऑफ बोविस एनर्जीज क्रिएट हो जाती है, और हिटलर इज द 1000 बोविस 45 डिग्री. इसी तरह से हम लोग अगर अजान पढ़ते हैं तो 15 से 25,000 स्क्वायर 15 से 20,000 एंटीनो बोविस जो एनर्जी क्रिएट करते हैं. चर्च के अंदर जो 11,000 बोविस के लिए एनर्जीज क्रिएट हो जाती है. तिब्बतन व्हील प्रेयर से 12,000 से 16,000 बोविस. एंड दिस इज इलेक्ट्रोकार्डियोग्राम जो हम लोग करते हैं, ये भी हमारी एनर्जी एक्सेस के ऊपर, एक्स एक्सिस वाई एक्सिस जेड से हम लोग हमारा ईसीजी हार्ट का करते हैं. और कंक्लूजन पे आना चाहेंगे हम इस वक्त कि हमने जो इतना डिजास्टर रेजिलेंस को डिस्कस किया, ये कि डिस्कस दिया था, फायदे क्या हैं इसके. दे आर जस्ट द multi benefits we have, like dimensions with technical, organizational and economic, social, health. स्टेक होल्डर्स में पब्लिक, प्राइवेट, गवर्नमेंट स्टेक होल्डर्स हैं. इसमें रेजिडेंस प्रॉपर्टीज हैं, लर्निंग, रैपिड, रिसोर्सफुल, रोबस्टनेस, रिडेंडेंसी, डिसरप्शंस, फ्लड, ह्यूरिकन, अर्थक्वेक, वाइल्ड फायर. बेनिफिट्स में फ्यू एडवर्स कॉन्सिक्वेंसेज भी है, रिलायबल परफॉर्मेंसेज एंड फास्ट रिकवरी भी है, प्रोटेक्टिंग इंफ्रास्ट्रक्चर, प्रोटेक्टिंग पीपल, प्रोटेक्टिंग सोशल एंड नेचुरल एनवायरनमेंट. And the conclusion is that disaster management requires a multidisciplinary approach and involve all levels of society, local, regional, and national, international. A successful disaster management system aims to ensure that resources are used to effectively, people are safe, and the damage caused by disaster is minimized. Therefore, disaster management should be a strategy that need to be continuously updated and improved. Disaster management and artificial intelligence application research finding and analysis indicate that the integrated system can be improved in the future stages to be on local and global scale. These systems can achieve more effective results by integrating artificial intelligence technologies into a comprehensive disaster management system. Integration of system can automate processes such as early warning, forecasting, damage assessment, and aid distribution. The success of artificial intelligence system to be used for disaster management also depend on the quality and quantity of data collected. Therefore, continuous and high quality data collection method should be developed. Disaster management experts should be specialized in this field, and the number should be increased for the effective use of artificial intelligence technologies. Integration of specialized individuals and effective system utilization will ensure qualified disaster management. The other important aspect of process management infrastructure assessment. Disaster management should be considered the sociological aspect as well as the physical aspect. Within this scope, management of multidisciplinary approaches is quite crucial. Artificial intelligence application in disaster management are not only a technological tool, but also require a multidisciplinary approach with disciplines such as social science, engineering, and economics. Therefore, although artificial intelligence applications are developed based on general principles, taking regional and local characteristics into consideration will increase the success of the applications. These are the different field and limitless, infinite. Thank you for your valuable time and attentions. Thanks a lot. Thank you.
Thank you, sir,
Thank
uh,
you, ma'am.
for a very informative session. Sir, one question wrote by Kush Verma, sir. I have a doubt in post-disaster cycle in the mitigation state. Please clarify.
Post.
I have a doubt in post-disaster cycle in the mitigation stage. Yes, Kush Verma, sir, has raised a hand.
Yes, yes. Just a minute. Let me.
Hello, am I
Yes,
audible, sir?
yes, ma'am. Yes, yes. Before disaster. Yes, ma'am. Yes, sir.
Sir, very good evening for your two wonderful lectures, first of all,
Thank you, sir.
and thank you very much also. And actually, I had opted for course on disaster management
Yes.
from some university. So I had studied something, but my doubt remains on mitigation stage. That is
Okay.
a post disaster stage. In
Mm-hmm.
mitigation, I'm thinking why it is at all there in the disaster management before recovery. Why it is should be there before recovery, sir. Am I clear, sir? My question is clear, sir.
Yeah, before you have written this after disaster, and we have here the before disaster. Yeah. Yes. Understand.
Sir, my doubt is in mitigation stage,
Mm-hmm.
which is post disasters, which comes in post disaster management cycle.
Okay. No,
And why, what at all, what in fact mitigation is, sir?
just a minute.
Sir, my question is clear,
Uh,
sir.
yes, yes, question is clear. Yes, you are read
Uh,
about the post and we are just taken the before. This is the
in
doubt. Yes.
that you think it should come before
Before, before.
before disaster?
Before
Okay.
disaster. Yes, yes.
What okay, what all steps are there in mitigation, sir?
Just a minute. I open the screen. I, I'd like to share my screen again back. Just a minute. Hello, screen is visible?
Yes, sir.
Yes. Yes. As before we discuss this mitigation before disaster, develop preventive laws and regulations, implement advanced codes and standards, establish zoning requirement by insurance and construction barriers. These are the hello.
Yes, sir.
Yes. Yes. हेलो
The points, yes, sir,
हाँ
the
पॉइंट
points
इज
are
दिस कि
clear.
भाई आज हेलो
हाँ सर, बोलिए सर.
भाई कोई भी चीज भ्रष्ट हो जाए उससे पहले हम उसको मिटिगेट कर लेना दैट इज बेटर है तो ये एक्चुअल में इसलिए पोस्ट की जगह बिफोर रखा गया है इसके अंदर हाउ टू प्रिवेंटिव लॉज बेसिकली मिटिगेट आउट
But sir, in disaster don't have any control. So if they can occur, then how mitigation can be applied, sir?
बट प्रिवेंशन इज बेटर देन क्योर वी
Okay,
कैन
it's working on that principle.
यस यस दिस AI सिस्टम बेसिकली
But budgeting and all constraint, we cannot, sir, prevent or prepare for all possible sets of disasters.
they are many factors they are working parallel.
Sir, you've talked about energy. Uh, do we have any, sir, magnitudes of forces as per your theory of Vastu Shastra, cumulative of which can predict some kind of disaster?
The Vastu is a different. Vastu is for the township, town planning, and disaster is different. But the man-made disasters created by human being, basically.
Sir, kuch sir.
Hello,
Sir, ma'am.
Yes, sir.
basically.
Yes, sir. Your
Hello, hello.
Yes, yes, sir, you are audible, sir.
sir.
और ये बोलना एनर्जी जो है ना आपका द रिस्पॉन्स जो है डिजास्टर एंड द वास्तु इज डिफरेंट दैट इज अ डिफरेंट लेवल ऑफ एनर्जी लेवल इज एडवांस हेलो
हाँ,
Kuch sir.
sir, clear.
hello they
Sir,
हाँ.
are
kuch sir.
that
Please
that is
mute
that
your
is the
mic.
man-made disasters
Yeah.
they can avoid the man-made disasters basically the why vastu hello you
Yes,
hear
sir.
me hello as we
Ha, yes,
discussed
sir.
the energies the man-made disaster which can be avoided by the vastu not the natural disasters but natural disasters if we have the right orientation and the directions then we can avoid it.
सर कुछ सर का ये कहना है कि शायद जो एनर्जी के थ्रू जो है क्या हम पहले से पता लगा सकते हैं क्या कि जो नेचुरल डिजास्टर अकर होने वाला है
वो
पहले से कुछ
एनिमल
assumption-
इंस्टिंक्ट्स हैं या इंट्यूशंस हैं उसके कारण से भी हो सकता है उसके अंदर बाकी मैन मेड डिजास्टर्स में डायरेक्शंस और जो एनर्जी लेवल है उसके कारण से वो नहीं है मैन मेड के कारण से होगा आपका पर वास्तु क्या कहता है द बेसिक प्रिंसिपल द फंडामेंटल जो है उसका द सिलेक्शन ऑफ द साइट द वेरी फर्स्ट स्टेज के ऊपर ही इसको रिडिक्यूल कर देता है कि अगर साइट जो आपके अनुकूल नहीं है तो वो प्रॉब्लम क्रिएट कर देता है आपके लिए तो आप सिलेक्शन ऑफ द साइट ऐसा लो ही नहीं जो आपको भविष्य के लिए तकलीफ दे
एग्जैक्टली कुछ सर
Yes, ma'am.
यस सर हाँ नाउ यू गॉट द आंसर सर कुछ सर
Okay, thank you, ma'am. Thank you, sir. Thank you for the answer.
प्रगति मैम प्रगति मैम हैज रेज्ड हिज हैंड प्रगति मैम no okay I think Professor Sumit Gehlot has also raised his hand. Professor Sumit Gehlot. Okay. Any other questions from participants? You can post in the chat box or you can unmute your mic. So I think no questions. Further questions from the audience. Okay. ओके सर कुश वर्मा सर ने एक और क्वेश्चन पूछा एनी प्रोजेक्ट टू वर्क ऑन MSM
MSM is full form?
कुश सर कैन यू अनम्यूट योर माइक यस मैम यस सर
मैम है वो इसी
Sir,
का.
that was ma'am, and that is ma'am. Actually, I was thinking if I can work on some project on disaster management. Sir, can you suggest some of the projects, practical projects, sir?
Disaster management practical projects. The city town planning. The before this you are stationed in which city?
This is Jodhpur, sir.
In the Jodhpur, you can disaster just like in the you have seen the rain in the rainy season. We have the over flooded. पूरा जो city है town planning का वो फेल हो जाता है हमारा जो फ्लडिंग जो रेन वाटर की वजह से. तो आप इसके ऊपर वर्क कर सकते हैं डिजास्टर से प्री डिजास्टर्स के अंदर जो ऑल अराउंड द सिटी प्रीमिसेस में है जो जिसमें से पानी निकलने की भी प्रॉब्लम्स हो जाती है शुरू हो जाती है अंडरग्राउंड वाटर लेवल जो रेज हो रहा है उस कारण से और काफ़ी चीज़ें हैं जो ट्रैरन है हमारा जो अरावलीज का जो मसूरिया पहाड़ी और पहाड़ी से निकलते हुए जो ऑल अराउंड जो जाता है ना आपका ये पानी पूरा बाहर की तरफ तो इनके सभी नाले सब बंद हो चुके हैं तो सिटी के अंदर ये सबसे बड़ा प्रॉब्लम है तो आप इसको काम कर सकते हैं इसके ऊपर अगर जोधपुर में है आप ये अपने आप में डिजास्टर एक तरह से इवन जो आपका सब्जेक्ट क्या है इसमें हेलो
Subject is disaster management as a whole, sir.
नहीं यू आर व्हाट यू वांट टू डू अभी क्या करना चाह रहे हैं इसमें आप
Sir, that's what I don't have any. I have thought process on disaster management since it is with multidisciplining. It involves civil engineering. It involves, as you,
yes
artificial intelligence now. So I don't have my faculties on finance, suppose say finance or commerce or civil engineering or even
नहीं you can
artificial intelligence.
this
So
is your
my selection is limited. Also, sir, as you have told, there is a there is hardly any data available for disasters
yes
management. So we cannot process using artificial intelligence. So, but data is actually main problem. We
yeah
cannot have any access if we come to know about any disaster. We do not have access over there, and it's dangerous at times. So it is very difficult to study such take or projects in disaster management.
but you have to work hard with your own datas and the old studies the city sewerage system you can take it out at the time of rainy time there's a very worst condition in the Jodhpur and we can discuss more I can give you the more clues on this subject okay
Thank you, sir. Thank you, sir.
thank you a lot
any other question from audience mic is open for all of you okay so no question
okay
from further questions from the audience so thank you very much sir for giving your valuable time and spare your time with us for the two sessions yesterday's and today's very informative sessions you delivered with us many many participants asked for your email id
okay
so can you type your email id in the
yes I
chat
have my in the card just I will give you please take the screenshot please
Okay. So all the participants, if you want to have sir's email ID, then you can take the screenshot for it. So, thank you very much, sir.
Thanks a
Uh,
lot.
Thank you.
Have a great day. Good night.
Good night, sir. So, today's two sessions are over here, and we will meet again tomorrow for the seventh session of the FDP. Thank you. Have a nice, have a good night to all of you. Thank you. Yes, feedback link we will share. Yes, Pragati ma'am, you want to say something? You raised your hand. Thank you, Sumati sir, ma'am. Uh, Thank you, Sumati sir. Siva sir. You all may leave this meeting.